In this video I will show the proof that square root of 2 is an irrational number, and I will do it by using the method of contradiction. So we are going to make an assumption that, the assumption will be that square root of 2 is a rational number. So we can write it as the fraction a over b. And now what's important, that a and b are whole numbers. Also b doesn't equal 0, and the one very important thing is that GCF, which is general common factor of a and b, is just 1. Okay, and we are going to start from this point. So maybe I just write it again. So a over b, and now both sides to the power of 2. So on the left hand side we're gonna get 2 equals a squared over b squared. The next transition is that 2b squared equals a squared, and from now there will be some implications. Okay, so what can we read from this? We can read from this that 2 is a divisor of a squared, and from this point we can read that 2 is dividing also a, and that means that we can show a as 2 times something. We can say k, where k is some whole number. So what we got is that a equals 2 times k. Okay, and now if we look at this bit, I will rewrite it. If we look at this bit, now the a from here I'm gonna substitute with 2k, and we are getting that 2b squared equals 2k squared. The left hand side we're just gonna leave as it is, but the right hand side of this equation, what we get? We get 4k squared. Then we can divide both sides by 2, and we are getting that b squared equals 2k squared. Okay, and now we've got a very similar situation to this what we can see above. Okay, so we've got same 2, a is dividing b squared, and another implication is that 2 is a divisor of b, and that implies that b equals 2 times something, and now we can say the next letter in the alphabet is L. So, and the L is again an integer. And now what we got? We got that a is 2k, yeah? B is 2L. And what we can read from these 2 bits? We can read that GCF of a and b, we can say that it doesn't equal 1, and here is the contradiction, and because of this we can answer that square root of 2 is an irrational number. And that is end of the proof.